Newton's second law of motion. This law states that rate of change of momentum of a body is directly proportional to the external force applied on the body, and the change takes place in the direction of the applied force. And according to this law, F directly proportional to delta P upon delta T, where delta P upon delta T is rate of change of momentum. Then F equals, we shall reduce the sign of proportionality, F equals K dP upon dt, where K is a constant of proportionality. If delta T tends to 0 means the time interval is very small, then the term dP upon dt becomes the derivative of dP upon dt. F equals K dP upon dt. For a body fixed mass m, we have F equals K d P equals mb d mv upon dt equals km dv upon dt, because m is constant. So F equals kma, where dv upon dt equals a, so F equals kma, and if k equals 1, then force equals F equals ma. This is the second law of motion. One unit force, if F equals 1 Newton, m equals 1 kg, and a equals 1 meter per second square. 1 unit mass into 1 unit acceleration. 1 unit force equals 1 unit mass into 1 unit acceleration. A unit force may be defined as the force which produces unit acceleration in a body of unit mass. Relation between Newton and dyne: 1 Newton equals 1 kg into 1 meter per second square, and then 1 Newton equals 1 kg equals 1000 kg, and 1 meter equals 100 centimeter. Then it will be 1000 gram into 100 centimeter per second square, it will be 10 to the power 5 gram centimeter per second square, and 1 Newton equals 1 gram centimeter per second square equals 1 dyne, then 1 Newton equals 10 to the power 5 dyne. Newton's second law in component form and its significance. And in terms of their rectangular component, the force, momentum and acceleration vectors can be expressed as: force in the component form F equals Fxi cap plus Fyg cap plus Fzk cap, P equals Pxi cap plus Pyz cap and plus Pzk cap, and acceleration A equals Axi cap plus Ayz cap plus A2k cap in the component form. From the momentum, from the formula of force in vector form, F equals dP upon dt equals ma. So F equals Fxi cap plus Fyz cap plus Fzk cap equals d upon dt Pxi cap plus Pyz cap plus Pzk cap equals m upon Axi cap plus Ayz cap plus Azk cap. Equating the component along the three coordinate axes, we get Fx equal to dpx upon dt equals max, Fy equals dpy upon dt may, and Fz equals dpz upon dpt maz. And next is impulse. Impulse is defined as the product of the average force and the time interval for which the force acts on the body, and the impulse is denoted by I. इम्पल्स एवरेज फोर्स और टाइम इंटरवल का प्रोडक्ट है. Thus impulse equals average force into time, and impulse is a vector quantity and the direction of impulse is same as the direction of force. impulse एक वेक्टर क्वांटिटी है और इसकी डायरेक्शन फोर्स की ही डायरेक्शन में होगी. Expression for an impulse: we have to consider a constant force F acts on a body for time dt, and then the impulse will be di equals F into dt. If the force acts on the body for a time interval from t1 to t2, then the impulse will be I equals integration of di. Then di equals F into dt, time interval t1 to t2 integration, limit will variate from t1 to t2, and F dt. If F average is the average force, then I equals f average integration t1 t2 dt, and the integration of dt will be t, then it will be f average into t and limit will vary t1 to t2. Then I equals f average upper limit minus lower limit t2 minus t1. Impulse I equals f average into delta t. According to the Newton's second law of motion, you know f equals dp upon dt, then f dt equals dp. Integrating both sides with limits, we get 0 to t f dt equals p1 to p2 dp. The momentum will be from p1 to p2, initial to final. F t is 0 to t and p p1 to p2, f into t minus 0 and p2 minus p1, f into t equals p2 minus p1, and then f into t is impulse. Impulse I equals f into t equals p2 minus p1.